All right. Good evening, everyone. I hope you can hear me.
Yes, ma'am.
All right. Okay. So there we go. Yeah. All right. So, welcome to the 6th live session of the course Introduction to Biostats. And so we're already in the 6th week of this 8-week course. And so after this, we'll have 2 more weeks of course, 2 more weeks of live sessions, and then you have your exam. So around the time when we are finishing up the course, let me know if you would like to have a revision session at the end. All right. And what you would like to get covered in that one. Yeah, you can put it up on the discussion forum, or you can let me know in one of the today's and next 2 live sessions. All right. And this is just basic. Okay, so before we start with this week's revision, do you have any questions? No questions?
Ma'am, that question is not re-evaluated. That black, knowing that card was black, Jack was coming.
Which one? Say that again.
Uh, when card is pulled, it comes out to be Jack, knowing something like that.
Yeah.
Knowing that the card is black.
Yeah.
Uh,
What about that question?
Ma'am, in one lecture, you are told that that question will be re-evaluated.
Yeah, so I think both answers should be correct or something like that, right?
Yes, ma'am.
Was it
But
not
not re-evaluated yet.
not reevaluated yet? Okay. So this was assignment 5, right?
No, assignment 4.
Oh, sorry. Assignment 5 we'll discuss it today. Yeah, assignment 4, the
Question number 2.
blackjack question. Okay, fine. I'll inquire about
Ma'am,
this. Okay.
ma'am, the answer is like that. It is blackjack. Answer is of blackjack. That will be 1/26. Jack, knowing that the card is black, answer will be 1/13.
It should be 1 by 13, yes. In the question, originally, I think 1 by 26 was marked as correct, but then 1 by 13 should be the
Ma'am,
correct answer.
in mathematics, how can we say that there will be 2 answers possible?
It will
In
not be
mathematics, only
possible.
one.
Yes, 1 by 13 is the right answer. But since they have, so the way they posed the question, they thought that the meaning that is being conveyed by that question is 1 by 26. So if somebody has also thought what they thought while framing the question, so they would have reached 1 by 26 as the answer. But the way we are interpreting the questions, only 1 by 13 is correct. But just to avoid any, so it's like a giving just the benefit of doubt, both the answers are being marked correct.
Ma'am, I have not got a mark on that question.
Sorry?
I did not get any mark from that question.
So what answer did you mark?
1/13.
Yeah, so you will get the answer correct. Like you should get marks for that. I will inquire about it. I'll inquire about it with the instructor and the other TAs who are handling the questioning part of the course, the questions and all. I'll inquire with them.
Ma'am, another question is that how should we put in those boxes? They are in question of
7 to
7 and
9.
9.
Yeah, so I
Yes.
just saw the question forum. So it says comma needs to be there, but it's not accepting commas, right? I think.
Yes, ma'am.
So I will inquire about it since we have time. The assignment is due next Wednesday. There are still 4-5 days. I'll inquire about it, and it should get rectified within a day or two. Okay.
Okay, ma'am.
All
Thank
right.
you.
Okay. Yeah. All right. Good. So if there's nothing else, we'll start off with a quick summary of this week. So, all right. So, I hope you can see the screen, right? So there are three broad categories in which you can sample a population. So this is what we had been discussing in one of the initial lectures, that there's a population and then you want to select some individuals from it. So what is the way out? How do you pick out some from a population? So one of them is random sampling. So let's say the population has 100 individuals. You want to select 20 of them. So you're just randomly picking. Okay, so that's random sampling. Now the other two, stratified and cluster sampling. So this should make it somewhat clear. So now these two are only possible when you are able to make a you're able to designate groups. So for example, see on the left side in stratified sampling, you could identify based on some parameters. Maybe let's say you are saying that the geographic location is a parameter. It's an aspect in which you can group these some individuals. The number of individuals need not be the same in each group. Okay, but it is a parameter that you can use for grouping. Okay, so what you did was, let's say there are 4 different parts of a city, for example, east, west, north, south, and then you have these groups of people, and then you are selecting uh, based on a proportion. So let's say if they are equal, you're selecting 1 1 1 from each. If they are different in size, you would select them in the same ratio. If a group is larger, you'll select more, and so on. Right, so there's an equal representation from each of these groups, something like that. Okay, that is stratified sampling. In the other case, in cluster sampling, what you do is you make random groups, not based on any criteria. You make random groups. So let's say you made like groups of 4. So you have a total of 25 groups, right? In the example, let's say when we are discussing the 100 people. So you made groups of 4, you have 25 groups, and now you want to select 20 people. Let's say so your sampling has to be for 20. So you'll say for 20, I'm going to select 5 groups. So so this entire is one group. You made a group and you selected the whole group. Here what you did, you made multiple groups based on a parameter and you chose one or two. You did sampling from each group, right? So this is a difference between stratified sampling, wherein you have made groups based on some characteristic, okay, based on some parameter. But cluster sampling, you do not use any parameter. The colors here indicate that there is an inherent parameter within the population, but that's not used directly. Okay, so this is just the starting of how sampling is done, 3 different ways. I think we did not cover it entirely in one of the earlier weeks where this was also discussed in the lectures. So this is sampling. And next up, there are 2 terminologies which are very frequently used throughout this week's lectures. So one of them is sample statistics and the other is sampling distributions. So once you have taken a sample, there are certain numerical values, some measures that you can interpret from that sample. You can have a sample mean, you can have a sample median, you can subtract something from the mean, you can divide something from the mean, so that becomes a sample statistic. So any numerical thing that you're calculating for a particular sample, that's sample statistic. Okay, and sampling distribution is that you would like to find the probability distribution of the sample statistic. So something like the expectation values and probability distributions in terms of expectation values and so on, right? So that's sampling distribution, because then you can make that nice value versus frequency curves. So that becomes your sampling distributions. Okay, so these two are also going to be used in the upcoming slides, and you would have already seen this in the lectures. Okay, so before we go into this week's topics, this is just a quick summary of what has been discussed in week 5, right? So expectation of any variable, whether discrete or continuous, can be written in these 2 terms. It's either the summation. So for discrete variables, remember it's particular value 0, 1, 2, 3, and so on. So it's going to be that value multiplied by its respective probability, and you sum up over all possible values of x. And for continuous random variables, what you do, you instead have the the integration formula, so x, fx dx throughout the whole range. And ideally, if there are no constraints, this range is going to be from minus infinity to plus infinity. Okay, so that's how expectation of a variable is defined. And you understand expectation means the most probable value of that variable. That's how you would just in a layman's terms, that's what expectation is, right? What do you expect to get if you roll a dice? What's the average value? Something like that. So expectation would very often give you something in terms of the mean, right? So for example, the expectation of expectation of x is said to be mean for any distribution, and then there are all these other certain transformation based formulas. So wherein if you want to find the expectation of that random variable multiplied by a constant and added to another constant, then basically the expectation of x plus b is a time expectation of x plus b, because a and b are constants here. And likewise, in case if you had here, so it's instead of ax, it's like, so ax basically can be written as x plus x plus x a times, right? So this whole thing is basically ex plus ex plus ex a number of times, and that's what is written here. Expectation of multiple random variables, xi's, uh, expectation of the sum of all these random variables is equal to the sum of expectation of individual random variable. Okay, and similarly, we can define the variance, right? So expectation of x square minus the square of the expectation of x, that's how variance is defined. And you also know it in terms of the formula, right? The default formula that we've used, we use it to solve it in Excel. And when you want to find out the variance of such a term, here you just need to be a little careful. So adding a constant to each value is not going to change the distribution shape. It's just going to shift the distribution left or right. Okay, so that p does not come up in the variance term, but multiplying a variable does make a difference, right? So it's going to be a square now. And now the other thing, in terms of variance, it's not a simple summation. There's an extra covariance term also involved. So this is until what we saw in the last week. And this is also something we had seen that this is normal distribution. This is a formula for the function of normal distribution. This is the value you get. And a normal distribution is defined by two things: the mean, mu, and whether you say the standard deviation sigma or the variance sigma square. So that's how it's defined. Okay. Now, this week primarily discuss central limit theorem. So what you need to remember for the central limit theorem, what you need to understand is, so you have a lot of random variables, x1, x2, x3, so all xi's. And now if they are independent, okay, so what you can do, if you define new random variables, for example, what we had also seen in the last week's like the last slide here, right? So summation of all these individual random variables, then what would happen is, so now here, this is what we also got in the last slide, right? So expectation of summation gives you n times mu. And now the variance here, it gives you n times sigma square. This was also defined extensively in the lecture videos. So you can take a look at the exact derivation there. That's mostly for your understanding. And now the different part which was discussed further here is that instead, now if you have another random variable which you are defining as the mean of these random variables, so this is that new random variable. So it's basically n, whether you divide each of them by n and then sum it up, or you first sum it up and then divide by n, doesn't matter. So summation of xi's divided by n, so that's the mean. So now if you do that, it's the average, right? So if you have a lot of random variables, you're taking the average, you expect the expectation value. Okay, so the here the mu remains unchanged. But now if you take the variance, so now here what happens is, instead of this n being multiplied in the denominator. I'm just telling it so that you can just remember it. Again, this n here becomes as the denominator, and this is how this whole thing. So these four formulas, or rather these two, so basically sum of I random variables and mean of I random variables. So these are the two comparisons that you can define, because these would make some sense in some real questions, and you have seen a lot of those questions in the throughout the week, right? So now what happens is, now how many i's are there? So that is, what is the value of n? So it is seen that what happens is that these new random variables, that is this new or this new random variable, it's going to follow normal distribution, right? Okay, so now we know normal distribution is something like this, and it's defined by the mean and the variance or the standard deviation. So that means the new variable sigma xi, for example, it will follow normal distribution, but its mean is going to be n mu. Likewise, it is going to follow normal distribution, but its variance is going to be n sigma square. Likewise, if the new random variable you define is the mean, then the mu is mu still, but the variance becomes sigma square by n. So that is how, so you're going to get a new formula. You can plug these values in this normal distribution formula here. So that's one way. But now it might be difficult to calculate normal distribution, the value of it. So what you can do is, you know all these values. So what you do, currently you define a new random variable, right? So sigma xi by n or sigma xi was a new random variable. Now you define another new random variable, which is z. How do you define it? You say it is this thing minus, this is going to be a constant term, and you divide it by a constant term. So what you're doing is, you're not changing the variable much, you're just subtracting and dividing it by newer things. And what these new things are, if you're subtracting it with mu and you're dividing it by the variance, do you remember there being a certain terminology we had discussed in one of the earlier lectures, that what happens when you subtract the mean from a variable and you divide it by the standard deviation? Do you remember what it's called?
Man, Z score.
Yes, right. So it's called the Z score, and that is why we are denoting it by Z here, right? So right, so what happens is, and what is the quality of Z score? Why do we calculate the Z score?
Know the outliers?
For outliers.
To see outliers.
Yes, you can remove the outliers. Okay, but why is it able to do remove the outliers? Do you remember there's something we said? So can you, so don't, maybe if you don't remember, that's okay. But what do you think subtracting mu, like subtracting mean and dividing by standard deviation, what do you think it's doing?
Normalizing standard normal deviation.
Yes,
Standard normal
normalize.
distribution.
Yeah. So I would not exactly call it normalizing, because normalizing can be slightly something different. It is a form of normalizing, but a better terminology would be, with the subtraction, you are centering your data. So now what happens is, now this new numerator, if you have, now you had a distribution, you had so many values. If you subtract mean from all of them, your data now centers around 0, right? So you remember, just draw this. Yeah, right. So what this thing does is, so let's say, again, same, I'm drawing a normal distribution here. This is the mean, right? So this is your leftmost or the lowest value of variable. So this is x, right? On the x-axis, we have these values, and the y-axis, we have frequency, right? So now what happens is, if I'm going to, so let's say each of these were my values, right? These were the values I had, and they occurred with a certain frequency. So now I am subtracting my mean. If my mean is mu, so here mu means the mean. So I'm subtracting mu from each of my values. Okay. No worries. If you did not attend the session, that's okay. The sessions are all recorded. Yeah, they're all on YouTube. The link for each of them is the same, and you can access that link from the course page itself. And anyway, so just mentioning, these live sessions don't exactly have an attendance associated with them, because it's not necessary you are free at this time. So if you feel like, you can always attend those sessions. You can just, see the recordings. And yeah, if you have any questions, you can post it on the discussion forum. Yeah. Okay. So sorry. Now, so if this is the distribution, so what I'm basically doing is, and imagine this is 0 now. So everything gets shifted by mu, right? Everything is going to shift to the left. So now, should have drawn it bigger, but okay. So now my new distribution is this, and the new distribution has a mean of 0. So this is what this numerator is doing, subtracting the mean. Why are we subtracting n mu? Because that is the new mean, right? Sigma x is our new variable, n mu is the new mean. So that is why we are subtracting it with this. So now we get a centered data. Okay. Now, what is this denominator doing here? So basically we're dividing it by the standard deviation, right? Root n sigma. So that's the standard deviation. Why do we divide by the standard deviation? What happens? Do you remember? What would happen if you're dividing? What does z-score do?
Basically, it tells under how many standard deviations the data will lie.
Yes, that is true. So the term I'm looking for is scaling, but that's the concept, correct? Right? So what it's going to do is, if you're dividing it, this z value is now going to have a, it's going to have a variance of 1, or the standard deviation of 1, right? So this new variable, so it's actually going to follow standard normal distribution, right? So this z value, it's going to have mean 1 and standard deviation, mean 0 and standard deviation 1. And now you can consider it to be a normal distribution. You can plug in the values here. So we'll come to that. How do you calculate the normalized, like how do you calculate the value of normal distribution in a while, right? So this is what it's done for the mean. And likewise, you can do it for the, this is for the sum, this value. And then, so the other thing, when you have the mean here, so basically, instead of n mu, you're going to write mu, and instead of sigma root n, you're going to write sigma by root n. And wait, so I should have written this thing here. Yeah, this one is going to be there. Yeah, so these are the two new z variables for it. Is there a question?
Ma'am, the second variable is for t-test.
Say that again.
Ma'am, is the second variable for t-test?
Which second variable?
That z equal to summation x I by n minus mu divided by sigma by root n.
Oh, no. So this is for, so we have taken 2 examples, right?
No?
Wait. So this is the sum, right? This thing is sum. And this thing is the mean, right? So when you're taking sum of your random variables, then the expectation of that new random variable. So we're talking about 3 things here. First is you have a lot of random variables, right? x1, x2, xi, xn, all of these. Now, so you are defining a new random variable, which is a combination of these random variables. And what is that new variable? You can say, let's say, okay, I'm taking the sum of these variables. So I'm just saying x1, x2, x3, I'm adding them up. So this becomes my new variable. Or the other option is I can say I'm going to find the mean of these random variables. So x1 plus x2 divided and so on divided by n. So that's also a new random variable. Now for each of these two new random variables, I can find their respective expectation value, which is supposed to be the mean, and I can also find the variance or the standard deviation. So this first row here, this is the expectation and variance of this sum, right? And the second row here is the expectation and variance of the mean of these random variables, right? And likewise, so when you define this, we say that each of these new random variables, whether the sum or the mean, each of these two are going to follow normal distribution. And what you can do is you further go one more step. So when we say normal distribution, we expect that the mean is mu and the variance is sigma square. This is what we say for a normal distribution. But now, since we don't have mu and sigma only, so we can just define another random variable, which is z. So basically, it's not a random variable, but we are actually finding the z score for each of these random variables. So we can say that this z score is now going to be your normal distribution, which has a mean mu and a sigma and a variance sigma square. So this is again for the mean, and this, oh sorry, yeah. So this is for the sum, and this is for the mean, right? Is that what you were asking?
Yes, no, thank you.
Okay, all right. So this is done. Now, so now this is, we understand that this is how you can you find you have a sum or a mean of existing random variables. You get a new random variable, and that is following normal distribution. So there are particular constraints that you need to just keep in mind. So if it is, so by the way, this is what is called the central limit theorem. Okay. Now, the original these variables, they may either have normal distribution by themselves. Okay. So what happens is, so now this you can take only, so only x1 is also normal. x1 plus x2 also is normal. x1 plus x2 plus x3 also normal. So you can have any value of n, and this central limit theorem is going to hold. But for cases where the original x is not a normally distributed random variable, for example, it is binomial, then the central limit theorem will only hold if there are at least 30 samples, 30 n's, 30 random variables that you are summing or averaging. Right? So that is just one caution. And now, so you would have seen a few questions of this week, and also in the lectures, a lot of places you, first of all, you solved it, in this terms. This term would be familiar to you from the lectures. So now you solve and you see what values you get. So by the way, you remember, so this is normal distribution, right? So basically what happens is, now let's say you're interested. So, and normal distribution is like this, it's never going to zero. So let's say, so what we are drawing here is basically fx, and this is x, right? Now the thing is that, let's say this is the area you are interested in. Okay, so the area is giving you the probability, right? This is what we had seen initially also. For any continuous variable, this is what happens, right? Now, so how can you define this? So let's say you have these few values. Let's say I'm calling this, I'll call this A, and I'll call this point B. So you can define it in a few different ways. You can say probability x less than B minus probability x less than A. Does this make sense? Or wait, what I can try. So what is this? This is basically this whole area, right? And what is this part? This is this part, right? So what I'm doing, the larger red part minus this black region here, it's going to give me this shaded green part here. Right? This is what I want. So this is basically probability of, sorry, it should be this. Oh no, sorry. It was right. Sorry. So this is basically A less than X less than B, right? Yeah. Try to understand this. I'll just write it again. Yeah. Right? Does this look okay? So this is one way of writing it.
X is greater than A, right?
No. So X less than A is this part. You see? This black area. So X is basically what you have on the X-axis, right? So this area, the one in black here, what I'm highlighting. Yeah, this part. This is X is less than A because A is here, so anything less than A. So what I'm doing is the red part, which is B and below, I'm subtracting A and below from it. So I'm getting between A and B. Right? Simple maths. You have a larger area. It's you can imagine it like a you need to find the area of, you've given one rectangle and you need to find another rectangle like this. Imagine this is there. You need to find the area of this thing. So what you do, the area of, so let's say this is rectangle B, the smaller one is rectangle A. So what is the area of this part, right? So you have area of B minus area of A, it gives you this area, right? That's the same what we are doing here. Yeah, it's just slightly, this notation is slightly difficult to understand initially. I also got confused, right? So this is one way you can write it, and we can write it in another way. Can you tell me in terms of greater than? That's not normally used, but you can write it. So there's one more way of writing the same thing. So here we are focusing on the left part, everything below B. What if we focus on the part above, A and above? Anybody would like to give it a try?
Greater than A minus greater than B.
Good, very good. So X greater than A minus X greater than B, right? So that's also how you can write it. Okay, so now how this is done is that these values, so normally solving this normal distribution is tough. It's not simple, it's complicated. So there are these things now. There are apps, online websites where you can just put one of these things, either X less than B or X greater than some value, and you put what is your mu and what is your sigma, and then it's going to calculate these probabilities for you. Now here, this is what we can do here in terms of your assignments and in terms of questions that we'll discuss today. But for the purpose of your exam, as far as I know, you will, if you are supposed to calculate something, then either your answer is going to be in terms of, what is this B supposed to be? That's it. That's where your answer is going to end. Or if you are supposed to calculate a step further, you will be given those values. You're not going to be asked to calculate the exact normal distribution formulas, right? So rest assured. So we'll just take an example at how you can do this. I think I have it open. Yeah, right. So here you can specify mu, which is going to be the mean. So let's take it as 5. Now, when I press enter, you see how the graph is shifting. Okay, right now the graph is centered at 0. So it's a centered distribution. Now I'll say mu is 5. So you see it's now shifted. Okay, the center is now at 5. And sigma, which is your standard deviation, let's say I'll say it's 2. So now currently the standard deviation is 1. So it's some shape. So now if I do it 2, it's going to get thinner, or it's going to get thicker, like more pointier or flatter.
Flatter, ma'am.
Flatter. And what do you think is going to happen to the height? Is it going to decrease? Is it going to increase? What do you think? Is it going to stay the same?
It will stay the same.
It will stay the same. Let's see. All right. Did you see what happened to the height? So earlier it was at 0.4. And now when I changed, it became 0.2. It halved. Right? Because see, the area under the curve has to remain 1. Right? So when you're flattening it, as in you're broadening it, you have more area being covered here. So you need to decrease it now. And basically this is frequency, right? So now if you have more values on the sides, you'll have lesser values in the center. Right? So this is how it's happening. So you'll just get a good idea of how the normal distribution is shaped. Yeah.
Fx in y-axis, that is following that formula, that equation that you have written in the PPT.
Say that again.
In y-axis, the fx, that is following the formula that you have written in the PPT that you have shown. That is why that values is changing.
Which values? These two values?
No, ma'am, please, can you go to the previous slide?
This
yes,
one?
For
this
no,
one?
Yes, for this normal distribution.
Yeah. This is the formula, yes. So this website is for
As
normal
the
distribution.
mu and the sigma has changed,
Yes.
so the fx has changed accordingly.
Yes, perfect. Yeah, sorry, I did not make it clear. So this is a normal distribution plot. So we know that this formula of fx, it is dependent on, so everything else you see here is a constant, right? So x is a variable, fine, but the only things you can change here is mu and sigma. So that is what defines a normal distribution, right? You give any value of mu and you give any value of sigma and you will have this normal distribution in front of you. So now the question that, so this is normal distribution. This is what your random variable is following. So you have if the mean is 5, you would expect that it's highly probable that you're going to get 5 or something around 5 as the value, right? If you have like chits, which are, numbers or student marks or I don't know, scores, whatever, it's following normal distribution, then basically it means that, so the probability of getting, so this is, you can imagine it as frequency or probability, right? Because the sum is 1. The area under the curve is probability, right? So that's what I mean by sum. So area. So now you can see that therefore the maximum height here is 0.2. So that's the highest chance in some units. That's the highest chance, right, of getting something around 5. And then as you go on the sides, the chance of getting that number decreases. So this is normal distribution. And now, so again, this software, this website here is to just give you an idea so that you can play around with it, try it a few times. The link is there in the PPT. So you'll just get an idea and you may familiarize better with normal distribution. This website by itself is not going to be there for you in your exam. But like I said, if you are required to find some value of some probability or something, you will be either given that or you will not be asked after that step. Maybe like just a step before and you'll stop your answer. Okay. So now, so we discussed, so what we saw here was that basically you are interested in finding some area. The total area is 1. You are interested in finding some area. So that's going to give you the probability. So let's say now this shaded region that we said, right? So here also, let's say I am interested in values between 2.5 and 4.5. What is the probability that my value is going to lie between 2.5 and 4.5? It's very similar to what I shaded here, right? So A becomes 2.5, B becomes 4.5 for this distribution. So can you tell me, so now, and yeah, and this is, so these are the options that are available. We discussed, right? X less, X greater. These are the two options we have. So can you tell me what should I enter here and how should I calculate further? Is the question clear to everybody? If not, let me know. This is an important.
2.5.
I'll write 2.5 here. Okay. Okay, and I'll press enter.
Then 4.5.
And what do I do with this? Less than, greater than, anything?
4.5
Sorry. First of all, tell me.
greater than
Greater than
greater
this.
than 2.5, greater than 4.5.
Okay, fine. So yeah. Okay. So now 2.5, this is my value. Okay, sorry. So it is 0.89. So
Ma'am,
okay.
this is for the discrete value. I think it is not giving for the continuous one.
It is continuous. Normal distribution can never be for discrete values, right?
Yes, but for 2.5, it is giving specific value.
So you see this, x greater than 2.5.
Okay,
This is the
yes.
probability that is calculating. Yeah.
But if I have the two value like 2.5 and the 4.5, then how we are going to put it?
Okay, yeah. So you see, now you see what is happening here. This blue region means this is where I'm drawing my line, and the red area means this is what it's giving me. The probability is equivalent to the red area. So the red area is 0.89. So what is happening here, it means that, so if I'm saying A is equal to 2.5 and B is equal to 4.5, this is what we are doing. So this value, I got 0.894, right? Likewise, now it's not a single step thing. Now I'll put 4.5. Now you see the shaded area is going to shift. So I'm writing 4.5 and you see it shifted. Now it's only this part. So now I got let's call it 0.6. Okay. So this one I get 0.6. Right? Now let's also calculate it the other way. So I'll say less than x. Now you see how it's shifted. For 4.5, it's this part, it is 0.4. And for 2.5, it is, let's say, 0.1. So this, this becomes 0.4. This was 0.1, right? So now you see, this roughly turns out to be 0.3. Considering it 0.9, so it's 0.3. And this is also 0.3. Right? We got the same answer both the ways. This shaded green area. So this is what you're doing. So whatever your question was, the most important part is to define these endpoints. So if you try and see if possible, go back and check these lecture examples. There's wonderful questions. So you check, and what basically in all the questions you're doing is finding out these two limits. What is the value of x between that you're interested in for that question? And once that is done, then it's basically you're plugging in these limits, whatever this a and b is, into such a program, or if you have like a list already, so basically plugging into the program, because calculating it is tough. Therefore, using a program, you are doing it either way, greater than or less than, and it's done. All right. So take a look at that. It'll simplify things. And let's go to the next part. So after this, there were just a few more things that were discussed. I think this was the last lecture. So now we talked about this term called sample statistics, right? It's a numerical measure. So by the way, this value here, this Z that you see here, okay, this is actually a sample statistic. It's an example of sample statistic, right? You can have a lot of it. So how did we define sample statistic? We said that these are numerical measures from the sample. They can be anything. So this is also a sample statistic, right? It's just a combination of some numbers here and there, right? Okay. So now whenever you are talking about a distribution, as we had already talked about in one of these initial classes, you might want to tell about the population by a single number, or you may want to tell about the population by a range. So initially we had discussed as single numbers, you can have mean, median, mode, and as range, it's basically the range, right? Minimum and maximum. So point estimate, again, it's the same, any one of these estimates. And since we are mostly talking about normal distribution, you remember an important property of normal distribution in terms of mean, median, mode? What is it?
They are all same.
N
They're all the
equals
same.
to mean.
Yeah, right. So point estimate, you can take any of them, that's mu basically. And the other thing is, instead of, so, and then we talk about the interval or the range. So now we not just talk about range, because you know that, so for a normal distribution, the range is basically infinite, like minus infinite to infinite, right? So that exactly doesn't make sense to say the range is what, because range of two very different distributions can be the same. So a slightly better descriptor is confidence interval, and what it broadly talks about is that what are the two values, what are the start and end within which a certain percentage of your points are going to be present. So remember the Chebyshev's theorem, this is on those lines, but slightly different than that, because that was sort of an underestimate, it used to underestimate the values, but it is sort of the same thing, but it's this one specific for normal distribution, right? So these values that I have here, they are only for normal distribution, right? So how you can say is that, so what percentage of values do you want to look at? If you want to look at 90%, so how can you write 90? So let's say if this is a notation we are writing, so 100 multiplied by 1 minus alpha. So if you back calculate 100 into 1 minus what gives you 90, so you will see that alpha is 0.1. Likewise for 95, it's 0.05. 98, it's 0.02, and for 99, it's 0.01. So for these particular values of alpha, we will see the use of alpha in one of the upcoming lectures. Okay, so you remember this. But for an alpha, you can appropriate, like correspondingly calculate these percentages. And for normal distribution, it's known if you're looking at 90%, then the confidence interval is basically going to be mu plus minus this sort of just to define, right? So this number goes here, right? This is that confidence interval. All right. So this is defined for 90%, it's 1.645 plus minus on either side of mu, right? So again, same figure. So this is there, this is mu. So if you want to find 90% of the samples, let's say, I'll try it with red. So if you're interested in 90%, let's say this is what is covering 90%. Okay, so this is the range. Now let's say if you want to find 98% instead, you want to find more numbers. So you have to extend, you have to expand the range, right? So it's going to be, let's say, between this and this, right? And that makes sense, right? Here you have 1.645 on either, 1.645 times this number on either side. And for 98, you have 2.33 on either side. I will recommend if you can just remember these four numbers, it will be simpler, just in case some question comes up, right? And now, can you tell me, do you remember what this sigma by root n is? From one of the earlier
Standard
classes.
error.
Yeah,
Standard
standard
error.
error.
Standard
Yeah.
error.
Yeah, standard error, right? Standard error of mean is also the same thing, right? Or is it different? What is standard error of mean?
Well, standard error of mean.
It's
This
the
is standard.
same.
It's the same thing, right? Yeah.
No.
So standard error of
And
mean.
then deviation of
And there
mean.
are other standard errors also from median mode.
You're not audible. Say that again.
And there are other standard errors from median mode.
I'm not sure.
There.
I don't think so. but I actually don't know. I'll have to check.
Ma'am, it's due to any sampling error or something, ma'am.
And we cannot have standard error for mode at least.
That is true.
And for median, we have range.
Median, you have range. The quartile system also is there.
Yeah,
right?
yeah.
Yeah, good point.
Like whenever we calculate mean, it is in the form of standard deviation.
Yeah.
And whenever we represent the data, if it is non-normalized, we calculate median in that case for the
That is
population.
true.
And then when we are calculating the median, then it is in the terms of range from minimum to maximum that we include.
Yeah, right. Good point. Thanks for telling that. Yeah. Okay. So this is what was discussed, I think. Yeah. Any questions? So I have already asked you small questions throughout the discussion right now. So I don't have a lot of questions. I think I have 4 or 5 questions, but they should be good.
Madam, hello.
Yeah.
Madam, in week assignment 6, they've asked calculate the Z value between -1 and 1. So will they give a Z table, madam? How to calculate for exams?
Okay. So you need to do this thing. For now.
No.
Yeah.
Yes.
For the exams, like I mentioned, if you are asked this, you will be given the values. You cannot be expected to know all the values, right? But I will still confirm this once more, and so that it's officially there. Yeah.
Okay. Is there any shortcut to calculate Z
For
value?
it was like sir was telling where the values will be for n will be from normal data. Normal distribution will be from the normal distribution table. So in that case,
table is this. Instead of table, the website, same thing.
Okay.
So like you remember earlier there used to be log tables, log file, anti-log. I don't know if you have seen that.
Yeah. Log tables were there.
Yeah. So very similar. So table for normal distribution also was there. But so yeah, so either you're going to be given either the table, but I don't think. Anyway, I will still confirm this so that it's there officially. Z table provided in exams. Or
basic, like otherwise they will just ask questions whether our concepts are clear or not.
True. Right. They will only be asked you, like if you are asked questions like this, you will be provided the appropriate material. You will not be because see Z value, yeah, I mean you can't be asked, right? Because a normal distribution by default makes sense for any value of mu and sigma. You know what mu and sigma for Z's is, right? That is different. But you cannot be asked, like you cannot be expected to remember everything, right? So as far as I know, it will be taken care of, but I'll ask. All right. So continuing from what you just talked about, do you all know this? What is the mean and variance of a standard normal distribution?
I'm 0, 1.
This is 0 and this is 1, right? Okay. All right. Now, okay, next question. What happens to the variance of a sample if the sample size decreases?
Remains same.
It remains same. Why do you say so?
Increases.
Okay. Whatever answer you're saying, why do you say so? One of you are correct.
And it will be increased because sample size is the denominator by n. So if it decreases, it will be increased.
Right? Yeah.
And so, basically the spread will also increase.
N increases, your new variance is going to, sorry, the question is it decreases. So this number is going to increase, right? Variance is going to increase and right, spread is also going to increase, right? Okay, good. Next is this. So this question, so I think you have a similar question in the assignment. So basically H0 stands for null hypothesis. You will be taught this in the next week. I think 7th week is when you're going to be taught this. But nevertheless, don't go into that direction. You just see what values you have here. And remember we talked about this test statistic.
Yes.
So what is it?
So here it will be like x bar minus mu, so which is our
Yeah.
minus mu divided by standard deviation.
Correct. Perfect. Right? So here you have 21.4 minus 20, and this is going to be
4.
4. Yeah. So this is 1.4 divided by 4, and that is 0.21. Is it? No.
Yes. No, 1.4 by
0.
Sigma by root n.
3.5, ma'am.
0.35.
You mentioned root n.
Oh, yes. Wait, sorry. Root n here also, right? So this is going to be 6. It's going to be multiplied by 6. So 0, 3, 2.1. Yeah. 2.1. Good. Thanks for pointing it out. Remember, this is this formula. This one below here. Right? This thing here, you see, this is mean. So x bar minus mu divided by sigma by root n. Yeah. I hope the calculation is correct. Any question? What happened? Everybody fell silent. All okay?
Yes.
Yeah. Okay.
Yes.
All right. Okay. Next question. So if the sample population has it's of size 36, and that's selected from a population which has a mean 100 and a standard deviation 15, what is the standard error of the sampling distribution of the mean? So standard error, right? So what's the formula?
SD by
2.5.
Sigma by root n.
2.5.
Yeah. One, just step by step. So sigma is 15 and root n becomes root 36. So that's 6, right? So 2.5. Now, just something you should be careful with. Don't mix standard deviation and variance. Standard deviation is sigma, variance is sigma square, right? It is, I have done this mistake long time back, multiple times, that if I had to use sigma, I'll use sigma square or vice versa. So your answer can, it's possible that they can give you the answer which matches if you would have incorrectly used sigma or sigma square. So just be cautious of that. Yeah. Okay. Yeah. So what about the standard deviation of this sample? Do you know that? If you were to, oh no, wait, I think, yeah. So the standard deviation of the sample here. This is the standard deviation of the population, 15, right? What do you think the standard deviation of the sample is going to be? Do you remember?
N minus 1.
N minus 1. Why n minus 1?
No, that is for standard deviation when we are finding.
That is for
X
the
minus-
formula. Yeah, that is the
For
basic
sample,
formula.
we will calculate root n minus 1 for standard deviation.
Yeah, that
Sigma
is the form.
X minus x square upon root n minus 1 for sample, and if we are calculating for population, we will calculate root n.
That is correct. That is correct formula. But from here, just going back to this table again, variance of the mean, standard deviation is root of variance, that way.
That would be root of 15.
Root of 15. No. So this is standard deviation of the population. Now standard deviation of the sample. So let's say in terms of variance. So the variance of the population is equal to 15 square, right? And now variance of the sample We know the formula. What is that? We just saw it.
By n, sigma square by n.
Sigma square by n. So that is 36. So the standard deviation of the sample, that is going to be 15 by 6. Same thing. Right? So standard error and standard deviation is the same for the sample. Okay.
Ma'am, in lecture 29, ma'am, one question is that in lecture 29, there was like point sample variance equal to population variance.
Yeah. So
Is it correct?
that is for a, but I did there's some confusion I have for that portion. So I will try to check that. But this basically let me confirm something. Yeah.
Yes, ma'am.
Yeah, I think I'm missing some point somewhere. I'll clarify this so that it's not, I hope I'm not wrong in this. Yeah, but okay. Okay, next question. A researcher wanting to obtain an estimate of the average level of some enzyme in the population. Okay, and what they do is that they take a sample of 10 individuals, determine the level of enzyme in each of the person, and they compute that the mean is 22. So now what is the 95% confidence interval of mu, so that the random variable, if the random variable has a normal distribution of variance 45, right? So again, what do you remember what number we are going to subtract and multiply? So it's basically
1.96. 1.96
Into standard error.
45
into standard
root
error.
45
Root 45
by 10.
by 10. Right. All right. Good. So can somebody quickly solve this? So this is mu is going to be like this is 22 plus minus root 45 would be slightly less than 7. So 1.96
It's the
into,
root and square root of n, no?
yeah, square root of,
Sigma by square root of n.
oh, this is also square root, right?
And we did 3 root 5.
True.
So root of 45 can be written as 3 root 5.
3 into 3 into 5, right? So 3 root 5 into 1.96 divided by
Upon
root
2.
5 by root 2.
Yeah, so root 5
So
can get cancelled.
So can somebody solve this? So, so again, when you're doing calculators, you can both find root of 2 or 2 to the power 0.5, 2 to the power half, right? Both of that is going to give you, so root of 2 we know 1.414, right? So 3 into 1.96 divided by 1.414.
$4.15.
Just a second. 4.15. Right, so 22 plus minus 4.15. So that becomes, when you subtract, it's going to be 17.85 minus 26.14. Maybe we've taken like, I think it's correct, but okay, this is the closest value, right? So that becomes our answer. So probably instead of 1.96, they might have taken 2. So that's also okay, I guess. But that's right. Yeah. So this is how you'll do this question. And
okay, because standard confidence interval is 95, so plus or minus 2 SD. That is the way.
Yeah. So
okay.
Anything. So yeah. So both the answers are okay. The answers are not very close. So that ambiguity doesn't matter. Yeah. So
I have one more doubt, ma'am.
sure.
But they ask the range of confidence interval means whether we have to add mean or just write the confidence interval plus or minus constant interval.
Okay. That is
No, whether we have
good.
here the
Yeah,
answers
yeah.
are they are adding mean and minusing mean.
Yes.
But in the week 6 assignment, they asked without any choice, they are given on empty space, asking for a range of
Oh,
confidence interval. So whether I should
okay.
add mean or just write the plus or minus confidence value.
No, so you will have to write the with the mean, because you see this value is a constant, right? You are no longer writing a range. This is a single value, right? You're
No, but they ask
subtracting.
for a single value, madam. They are asking a single numerical value.
Oh, for question 7 and 9, is it?
No, in week 6 assignment.
Week 6 assignment, yeah. So question 7, 9 or something else?
Yeah, I don't remember. But they ask, they give me a hint also. One numerical value. How can it be a single numerical value? The range they are asking. I can write whether a single value or then.
So just a second. So today morning, I think you would have received, today morning or yesterday night, you would have received an email for particularly
Yeah, ma'am.
question 7 and 9, right? So there, as far as I remember, they said that you write smaller number, comma, larger number, but that's not accepting commas. Is
But
it?
not possible to
Yeah, yeah.
write the comma.
No special
Just
marks are
the
allowed.
dot accepting, but comma is not accepting.
One by one, please. One by one. Yeah.
Ma'am, comma is not accepting.
Comma, it's not
Only
accepting.
dot is accepting.
Okay.
No,
And
plus or
space
minus
also
also not
not
accepting.
possible to do.
Okay. I will confirm this. I'll just send them an email
Two
right
questions
after.
like that, ma'am. That's right.
Yeah, question 7 and 9 are both like that, right? Yeah.
Thank
So
you.
yeah, I will confirm this, that if it's a single value, then of course you're writing this part. But if it can accept a range, then this is how you're going to write the range, like with a comma or with a dash, however it's mentioned in the question. Okay, good. Just a word of caution. I think I might have mentioned something incorrectly here in this part, so you forget this for now. Really sorry about it. I'm thinking about it now. I think I'm wrong somewhere here. So just remember the top part of it, right? Standard error is what formula you know. I will clarify this and I'll send you an email like on the discussion forum. I'll clarify this. Okay, all right. So that ends week 6 discussion. So we'll go to week 5 assignment now, right? The solutions were released. So let's just take a look at that and see if there are any questions from there. Okay. Yeah. Okay. So this one, that's okay, right? So this is not X, this is multiplication, by the way, because here X is denoted as a capital X. So don't get confused. And then this also formula we have seen last week, we've seen this week also. This is the formula that holds. I hope you're all clear why there's a 2 here.
Yeah.
Yeah. So remember from the formula, it is a double summation. So it's going to take into account all your combinations twice. If it's 3 variables, then also it's going to be twice. 4 variables, then also it's going to be twice. Okay. All right. Sorry. Next question is, so
yeah, for this question, the options, the C is correct. Like for me, it was, I mean, that was correct. But why plus? It should be minus.
Minus, yes. It's the question, like
variance
the
itself is
format
like minus your the summation of total.
Right. So this is incorrect. Right. So
oh, we have been awarded, I mean, given the points, but it's not about point. It's like
yeah, this is incorrect. Right? Because you see, this is the formula, right?
By the variance formula itself is like.
So also, this is supposed to be expectation of x square minus square of expectation. This is sort of like it's not just about minus, it has to be the second term minus the first term. Right?
Yes, ma'am.
So
yes.
The answer is incorrect. So ideally, everybody should get marks or nobody should get marks. But everybody should get marks irrespective of what they've answered, because there's no correct answer. So question number 3 from assignment 5. Noted. All right. This one we just talked. Mean median mode is all the same for normal distribution. And if x is uniformly distributed from 0 to 100, what is the probability of x lying from the range 20 to 80? The keyword you need to remember here is uniform distribution. So simple calculation, right? Numerator becomes your range of interest and denominator becomes your total range. So 80 minus 20 divided by 100 minus 0. 60 by 100, so that is 0.6. Right? And this is why it's coming up like this, right? So because 1 by this value goes outside the integral, so you are basically integrating dx. The integration of dx is x, and your x goes from 20 to 80. So it's going to be 80 minus 20 by 100 minus 0. Same thing. Yeah. Okay. Which of the following is not a continuous distribution? Binomial is not a continuous distribution. Okay. And so when the mean is large, Poinsot becomes similar to what distribution? This we had talked last week, right? Becomes normal distribution. And suppose a class has 250 students who have recently participated. Sorry, yes.
So last week we had a discussion related to Poisson and
We
binomial
talked
distribution.
it will
But
convert
this
into
discussion
binomial
went
distribution.
within the session. When mean is large,
Binomial?
the Poisson distribution becomes similar to. We had
Yeah,
a discussion
right.
between Poisson
And
and
when we had
binomial.
discussion also that whether vice versa is possible or
Right.
not.
It's not normal. Oh.
And
Good
even
point.
in the video sessions also, Sir not yet covered this type of topic.
Right. Okay, no, it's not supposed to be normal then. It's supposed to be binomial.
Even sir mentioned in the lecture.
Yeah.
No, madam, we had a discussion related to N and P.
Yes. N and P and
But here
lambda.
they asked about mean is large, and they're asking relation of Poisson with other. But even this topic, that means relation between
This
the
part
Poisson
was
and
not
normal,
covered.
it is not yet covered in the video sessions also. Even the last week we had a discussion related to Poisson and binomial only.
Right. Okay. So this was not discussed, right? Outside. Okay.
And that discussion what we had, that is related to N and probability.
N being large.
And being
larger and
yes.
probability only.
Right.
Related
N
to
large and
NNP,
P small.
NNP and how we can relate the Poisson and binomial only. But here the term is they used in the question mean.
Okay.
And related to I think maybe question is not discussed. Maybe it is in the concept, but we didn't had this.
No.
This
Okay,
is not
right.
covered.
This was not covered. I understand. Sorry, I thought something else. So yes, this is not covered. I've noted this down. I'll post it to the group, like to the instructors. Okay. Yeah. All right. So suppose a class has,
So in question number 8, so like what I was thinking in terms is like, since we have the students test scores which is mostly clustered around 55, right? So, and with very fewer students scoring significantly higher or lower, so why couldn't this be a characteristics of a normal distribution?
This is normal, right? The answer is normal distribution.
Yeah, so because since the options, I mean, we were discussing just about like it should be binomial distribution.
No, we were discussing no. So binomial discussion was from the last week's thing. That binomial, what was discussed with binomial and Poisson and n being large, and all of that was for question number 7, not for 8.
Okay.
Yeah.
Okay.
So for 8, it is normal distribution. So like you mentioned, it's clustered around 55, and it's a relatively broad distribution. You can see standard deviation being 12. So it's broad, and so it is a normal distribution, right? So that's expected.
Ma'am, I have a doubt about 8th question.
Yeah.
Ma'am, is there anything means we can calculate and find out that this gives a normal or some formula which satisfies this condition?
Yes, but yes.
No. So when you have the values, exact values with you, right? What is x1, x2, x3? So then there is something called, what is the test name? There's one test, I'm forgetting the name, which is a test for normality. What is it called? Let me just search.
Chi-test or t-test?
No, it's called Shapiro test. Yeah, so that's used to test for normality. So like, let's say you have a distribution of whatever 1,000 values and you would like to see if it's following a normal distribution or not, or just 50 values, whatever it is. So then this test, I'm not sure how this works, but there it tests for normality. But of these options, normal distribution is the one that fits, right?
So only just by considering the broader range of the
Yeah.
and all.
Yeah.
Yes. Okay.
Okay. This terminology was explained, right? So probability of s plus t, like x being greater than x plus t, given one of these has happened, is same as the probability of that added value. So the memory component is like, it's not dependent on something happening before or not. That's exponential, right? And this question, so I've seen again in the discussion forum that there's some confusion with how the question has been framed, and I agree with it, because it says for any point, right? For any point means any point, but what they meant by 0 is for a point. So I will ask this also, right? Because it's not clear. Any point indicates
Answer should be 1, no?
Answer should be 1 by how they've said. Like any point means you have the total range with you. But the way they framed the question, in like while framing, what they had in mind was for a point between 0 and for any single point. But that's not conveyed adequately, which is why 0 doesn't appear to be the right answer here.
No, I think we had a discussion on this question last week also. Any point means it is a single point. For single point, area is 0.
No, so it depends. So the way I would read it, any point. So it's like
Any point, you can take all the points of
Exactly. So this question is slightly ambiguous in one way of interpretation. So everybody who's answered is actually correct in their own sense. If you have thought of a single point.
Well, ma'am, sir had mentioned in his lecture that the probability associated with a single point, and he mentioned
Correct.
that any given point would be always 0.
Yes, that is, you're all correct. So if you have thought of the question as being like a single point, any point but a single point, then the probability 0 makes sense. But how some of us have also read it is for any point. So it could be between 0 and 100, probability of getting any point. Like here, the question said the probability of getting between 20 and 80. Now here I'm understanding getting between 0 and 100, any point. So 0 by 100, like 100 minus 0 divided by 100 minus 0, that's 1. So in that way, 1 is also correct. So it's not correctly framed for a single point or for any point between these things. So both the answers are actually correct, depending on how you read it.
And if it is continuous variable, which is a uniformly distributed,
in mathematics,
on any given
that
point,
one by one.
how it could be 1 from 0 to range. Like if we are...
Rena, say that again.
Now in mathematics, how can you say that 2 options be correct?
Which one?
And how can you say in mathematics that 2 options be correct? This is
I am
like an
saying this.
impossible.
No, I'm not saying in mathematics 2 are correct. I'm saying depending on how you are reading the question. So the way I would read this question is that.
English like.
Right. So that way I'm saying 2 answers are correct. So which is why framing questions is very important. Right? How you are framing, because there should not be 2 interpretations. Right? So
if this question, for example, if any point means, like, for example, if any single point is there, then we are supposed to write.
So which is why had they written any single point, then the answer 0 would be Correct? Nobody would
Correct.
have any question about it. But when you say any point, I can say this is my whole range and I can take any of the points. So definitely I'll get one of the points.
Okay, so that is like one is not a number. One is like we will get any 1 point at any.
One is the probability one. That all points. Right.
If we say anyone, then anyone means everyone.
Any single point, like just a single point. Why? Exactly.
Okay.
This question has to be framed very differently for it to be unambiguous. Right now, even modifying it is not clearing the confusion. So we'll discuss this. Yeah. So from this assignment, question number 3, none of the answers are correct. Right. Question number 7 here. This part was not discussed. What was discussed was Poisson and binomial for large n and small p, but this large m Poisson and normal was not discussed. And for question 10, this both 1 and 0, they're both turning out to be correct. I'll ask that. Other than that, assignment 6, question 7 and 9, do you have to write the range or do you have to write just the plus minus part of it? That. And if you have to write the range, it's not accepting commas right now. And then for question assignment 4, the blackjack question was not remarked, so that needs to be done. Anything else that I'm missing? That's all from our discussion, and I will also confirm this part that I think I messed up this, so I'll correct that.
This standard deviation of a sample is this the same which we talked previously about standard deviation of population and standard deviation of sample, which is two separate things.
So so the thing is, so that what we discussed was when you are calculating the sample deviation, standard deviation, when the value n, is it a population value or is it a sample value? Here we are saying from a population of some 100 or 200, we are selecting 36. So then what is the relation? That is very different. This is very different.
Okay.
That is for the same n, is the n denoting a population or is the n denoting a sample?
Okay.
And here the n are different. We are talking about two different n's.
So ma'am, here if we read the question, the sample population is size 36. So here 36 indicates the sample population out of the total population. Here total population is not given. So
it's not
n
given.
is basically the sample only. So if we consider that part, then standard deviation of the sample would turn out to be x by x. X bar minus x the whole square, x minus x bar the whole square upon root n minus 1 the
yes. So here you don't know x and x bar, right? Like at least you don't know x, each of the values. So that calculation you do when you have been given each point.
Frequency table is given.
Yeah, exactly. So this, I think what I've written here is actually wrong, but please forget we discussed this. It's only the first part of the question that is important. Standard error, we are sure of the formula. I think standard deviation, what one of you mentioned, it should be the same as the population standard deviation. So that what sir derived. So 15.
Yes, ma'am, there it is. Yeah, in lecture 29, there was a point, sample variance equal to population variance.
Yeah, I think that is what it should be. I'll just correct it here itself so that it's... why is it not recording? Okay. Anyway, let me just delete this. I'll rewrite the whole thing. Okay. So this, what we calculated was 15 divided by root of n. That is 15 by 6 and that is 2.5. So we get this as the right answer. And standard deviation is same as population standard deviation. So that is equal to 15. Right? So that's what it is, right? Yeah.
Yes, ma'am.
Okay. Thank you so much for clarifying this for me.
Ma'am, I have one doubt.
Yeah.
Ma'am, like when sir was taking lecture for uniform distribution, he told that if you are having a sentence that average number of cases in a day or average something like that, then you should consider that it means lambda. they are indicating about when we are
Okay.
solving the population. Now, in such cases, if we are asked that average is this, like, so when to consider it as a mean and when to consider it as a lambda.
So you remember lambda is actually equal to the mean, right?
Lambda, yeah.
So it now depends, is it going to follow normal distribution, or is it Poisson, is it exponential, is it binomial, that ways. That is important, which will be indicated in the question most likely. It is going to be
So
indicated.
mostly if it is a uniform distribution, they will be telling that it is a
uniform. Yeah, uniform you'll understand is going to be uniform. Uniform is that straight line.
Right.
Uniform doesn't have lambda, right? So yeah, it will be clarified. Okay, all right. So that's it. So today we finished it well in time.
Excuse me, no?
Yes, sorry.
Can you please open the central limit theorem page, that slide?
Yeah. This one?
Yes. So here you mentioned and the variable defined by z, and likewise for the variable z. Actually, we can convert this to z. Both are same only.
So this is basically in first case. So I'll just explain you one more time. Just listen to it carefully. So you have a lot of random variables, x1, x2, x3, xn. Right?
No, madam. I got that point with explanation, but here the mentioning of z equal to summation of xi minus n mu by sigma square root n, and here this lower term summation of xi minus
this is
mu
xi by n. Xi by n.
Xi by n.
Yeah, this is mean, right?
Okay. If it is xi by n, then
yeah, I will, before posting it, I'll just correct it so that it's clear. I missed that term there. Yeah, it is for each of these new variables.
Okay.
Yeah.
And related to this confidence intervals, after calculation we'll get two values.
Yes.
With addition and with subtraction we'll get
right.
So can we consider these two values as a maximum level and the minimum level for that given intervals, given population?
It is, so you can say
in a given sample. So while calculating the calculating range, we will consider the maximum value and the minimum value.
Right.
We'll subtract that. Then we'll get the range is a single quantity.
True.
Single value. So in case of confidence intervals, also we'll get two values of taking that range. Subtraction and addition will get.
Right.
So in that condition also will we get a range?
So now you see what a range signifies is that 100% of your population is within that interval.
Within that range.
Right.
That means upper limit and lower limit will get. So there is a chance here can we subtract the two values, then we get the range again.
You will get a range, but that is not the range of your population. That is the range of getting 99% of the population or 98% of the population.
But right? In the assignment 6, what they ask about range only. In one question,
assignment 6, assignment 6 again, question 7 and 9 is what you're talking about, right?
In that very 7th question, they ask about range. Then after finding the intervals, we have to subtract that and then we'll get the range.
Okay, fine. I will clarify this.
Okay.
So that you have enough time. So we have basically three options for that answer. It's either just this value. So let's say 1.645 into this. Either you're writing only this, or you're going to write the double of this, which is basically your range, right? It's equal on both sides, so it's double this range. Or the third value is that mean minus this value, comma, mean plus this value. So there are three options, right?
Okay.
Yeah, so I will clarify which of them is correct. All right.
Ma'am, another thing, ma'am, can you please refer us a book for what series in this structure going on?
Okay, I will let you know.
That is available online. The probability and statistics books one is for probability and statistics. My member Beware, and the other one is for engineers and scientists.
And you
reference books are mentioned in the on the website, I guess.
Okay, okay, yeah. I also have the names of only those two, I think.
Mental behavior.
You can check it on the course page then.
Yeah, the reference is available, and those two books are available online.
Okay, that's great.
Like ebooks, like we can get the
Okay.
PDF downloaded.
Okay, okay, that's great. That's good. Yeah, thanks for sharing.
Thank you.
All right. Okay, so that's it then. Anything else?
No, ma'am.
Yeah. All right, so I'll just stop sharing. And all right, thank you so much. It was very informative for me. I made a couple of mistakes, but our discussion clarified it all. So thank you.
And biostatistics is anyways little bit confused.
It is confusing, and a discussion always helps. Like even until now, whatever work I do, we discuss. I'm working on something for a year, but now I feel, oh, I've understood it in a better way. So yeah, always keep discussing. That's helpful for everybody. All right.
It is like when you post an article, post research, when you're publishing the article, actually then you get to know that, okay, what was the meaning of that
True.
statistic, what we did.
When you're seeing it
And
in the whole picture.
And at that time, we would felt that, okay, this variable, something could have been calculated in this way, or some mistake we have done in statistics, or some taking some variable or something like that, and we could have done this better way.
Yeah.
By doing
True.
research, like making the research protocol itself.
Yeah. Okay. All right. Thanks, everybody. Have a good night.
Thank you, ma'am.
Yeah. Bye-bye.
Thank you.
See you next week. Bye-bye.